Samuel Mather, a first-time PostGIS presenter.
Yes,
Um,
indeed.
First of many times, I assume.
That's the hope. Yes.
He comes to the topic with fresh eyes, and we're looking forward to hearing what he has to tell us about PostGIS, PG routing, and isochrones, which have to be some of my favorite crones. Samuel Mather, I understand you're of the Cleveland Mathers.
Yes, I am. Yeah, I am. I have some expertise in my little corner of Cleveland that I pulled on for this project, uh, which I'm excited to share.
All right, so feel free to take over the screen share, and
Let's
I
see.
can, waiting. I can see your screen,
Excellent. Okay. Uh, let
and it's big.
me
Good.
not used to this little bar. This thing's new. How do I minimize? There we go. Okay, yes, hello. My name is Samuel Mather, and I am here today to talk a little bit about my experience with service-oriented isochrone mapping with PostGIS and PG routing. Um, so I am a high school student at the Mastery School of Hawken, which makes my use case for PostGIS perhaps unique among those presented about today. It's a smaller project and my first with PostGIS PostgreSQL and any database manager. Um, but I think it's a pretty interesting one. By way of context for Mastery structure, we're completely gradeless. So we demonstrate our mastery on our transcript through um, instances of applying the skills that are deemed necessary to have before graduating high school, usually through community partnerships. Those are kind of the catalyst of our learning structure. So in any given class, we'll have three partnerships, um, and our partners will give us a challenge, which we will work towards addressing in teams of four. And this term, I took a class on epidemiology, and we had um, two partners whose challenges to us prompted me to use PostgreSQL and the PostGIS extension to address their challenges. The first of those two partners was the Cuyahoga County Board of Health. They have a points of distribution system, pods, um, which they operate when there is some emergency in the community that necessitates the distribution of emergency resources. So that could be like a chemical spill where people need cleaning, or a pandemic like we saw in 2020 where people needed vaccines, or something that causes a food or water shortage. Um, and basically, they wanted to make these points of distribution more accessible to a greater number of people with disabilities, or uh, people above a certain age who might not be as able to transit long distances. And then we also worked with the Greater Cleveland Food Bank, who were looking for local food pantries to whom they wanted to distribute a greater amount of produce using a specific protocol called the pharmacy program. Um, and they were looking for pantries that were high capacity and in areas ideally with a high need for more accessible, high quality produce. Um, for the purposes of what I'm going to be talking about in this presentation, I'll mostly be focused on my time working with the Cuyahoga County Board of Health. That was kind of where this process all got started for me. Their challenge language that they gave us, they asked us specifically to use data and community input to recommend how they could make pod locations more accessible for people with disabilities and transportation needs. Um, and there are kind of two main pieces to that, the more data-facing piece and the more community-facing piece. And I wound up very focused in my team on the data-facing piece because I wasn't as able to get out in the community as some of my teammates. And I really wanted to find a way to visualize access to the pod locations by roadway. That was an idea that I had, and I was asking my father about it, who is a GIS expert himself. And he told me about isochrone and isodistance maps and advised me to literally take a page out of his book and pointed me to pages 223 to 232 of the first edition of the PostGIS cookbook, which he co-authored, which detail how to make isochrone and isodistance maps. He schooled me on managing a database in PostgreSQL, and I found myself in a situation where I was working with code that is very old and not compatible or efficient with the latest version of PostgreSQL and the latest version of PostGIS. So the task that I took on in that partner challenge was revising the code to work with the current version of Postgre and be as efficient as it could be, and then write it all up in a format that was accessible to the Board of Health so that they could use these tools in future for visualizing roadway access to their pod locations. And I include this photo. PostGIS has been in the background of my life for as long as I can remember. Um, but I have not until now had a chance to really explore it. So this was very exciting for me. So just to briefly define isochrones, though I'm sure many people on this call are familiar. Um, if we have a buffer map where the we have a point and the buffer has a radius of distance x away from that point. Um, Presumably, if this exists on a map somewhere and there are roadways extending from that point past the borders of the buffer, they will not travel in the most direct path possible to leave the buffer. They will probably wind around a little bit, and thus distance x along the roads is probably not going to be is not going to go as far as a buffer with radius x. So when visualizing access, we can basically shrink wrap a buffer around the roadways, I guess is one way to think about it. So that a buffer of a certain size is represented in terms of a distance along roadways instead of distance in the purest sense. Um, and actually, what I'm mostly working with here are isodistance maps, but my spell check says that isodistance isn't a word, so I've rather inaccurately used isochrone in most places because it is a much more convenient word to work with in Microsoft Office. So the deliverable structure that I created for my challenge partners was I gave them ISOs at 1,500 meters, 1 mile, and 5 miles from each of their pod locations, using walking distance along roadways for 1,500 meters and 1 mile, driving distance for 5 miles. I created a map overlay with census data for visual comparisons between areas of accessibility and areas of high risk/need. And then I also gave them the actual code for their future use. And I'll quickly give the recipe, I guess, that I used to make this all happen. I started with a set of points. They had everything. They didn't actually have a map of all their pod locations. Like they didn't have any way to visualize access. So my team had to do some geocoding to make this happen. Now, these are not the actual points. Where their pod locations are in Cuyahoga County. They do not want those to be revealed to the public. So for the purposes of this presentation, I'm using a randomly generated set of points that will be our fake pods for these purposes. I then imported some OSM-derived roadway data via GeoFabric, which I used to do the actual Dijkstra routing. Like those were the routes that I was running through, and those had walking distance and driving distance, which I used respectively at the different distances. And then I also imported some census data that was relevant to the nature of the challenge for the purposes of this example, households without a vehicle. And then the tools that I used, Postgre, obviously, PostGIS, and then I compiled everything in QGIS. The two of note are I used PGRouting to actually perform the Dijkstra routing and OSM to PGRouting to make PGRouting be able to read the OSM-based roadway data that I had. So this the code that I revised from my dad's old code to make this happen utilizes two functions. The first is a fairly simple function that takes a point on the map and locates the nearest piece of the roadway. and marks that and makes a list for all of the points, all of the pod locations where the nearest bit of roadway is. Um, and then it gets fed through, those points get fed through this function, uh, the first half of which is shown here. Um, and oops, sorry about that. Um, This is the part that actually does the Dijkstra routing. So this goes out along the roadways at the distance that is specified, um, and then creates a concave hull in this part of the function around the endpoint of those distances to create the isodistance map, which then looks something like that. And then this is the piece that ties those functions together. It's pretty straightforward. The two bits that change frequently when making different isodistances is just the number of isodistances, the distance specified, which is that number at the far end of the uh, parentheses in the indented section, and then which data set it's pulling from. So these are some examples of the products that I was able to generate. Obviously, the stuff that is tied to the pods is random points. So this was not our actual deliverable, but this is representative of one pattern we were able to very easily identify using this visual medium, which was that there were certain areas on the edges of the county. Where there were town centers that did not have any pods in them or near them. This shows ISO distances from pod locations at 5 miles, and we can see that Reminderville does not have any within 5 miles along roadways. Um, we can also use this method to very simply and easily visualize areas where there's limited access at scale, which was something we were able to do as well for the Cuyahoga County Board of Health, in addition to giving them the code. And then we were able to recommend locations within those service gaps to institute new pods. And then you can also easily compare between different locations, which are more accessible by foot. So obviously, in this case, the one on the right is far more accessible by footpath than the one on the left. Um, Now, I can show you the deliverables for the Greater Cleveland Food Bank since it's common knowledge which of the locations in the Cleveland area are food pantries. This was one of our deliverables for them. We showed them, we narrowed down their highest capacity pantries, and then we created ISO distances around those high capacity pantries and visualized it over top some census data showing food insecurity in the area so that we could identify which of the locations that could take on the produce that you want to distribute are in high need areas. And we were able to identify a couple straight away. Um, so there are some limitations, next steps to this process. Obviously, it's not a true isochrone since cost was not a factor. We weren't considering travel time or like terrain difficulty or anything like that. Um, and there is some potential there to deepen the analysis. There's also potential here for a proportional disaggregation of the census data relative to the concave hull created in the isochrone making process, which is something that I'd like to look into developing this further. And it's hard to know the exact impacts that these deliverables have had or will have because the one drawback to our community-oriented system is because we move on so quickly to the next thing, we seldom follow back up with community partners. So yeah, it's hard for me to know exactly how this got used or will get used, but it is something that I tried to make accessible to the partners. And I guess just generally, this being my first foray into using PostGIS and PostgreSQL, a big takeaway from me was that database management is not nearly as scary as I thought it would be. And actually, the way these things are set up and the guides that are out there for getting started actually felt very accessible to me. And I guess would like to express some gratitude to this community for setting things up in such a way that I could make an impact on my own local community here using these tools and get started so quickly and easily. A couple other thanks are in order. Thanks to Stephen Mather for his mentorship, provision of resources, and consultation during this process, and to my challenge teams for their support, particularly from the team Sweet Peas, which was working with the Cuyahoga County Board of Health, Catherine Bolin, who did the geocoding manually, which was crazy and impressive and very useful. And Jonas Baird from epidemiology, which was the team I was in that was working with the Greater Cleveland Food Bank for finding the census data and information on food insecurity, which was more difficult than we expected. Yeah, that's what I've got, and I will now address any questions.
Well, if anyone has questions for Samuel online, put them in the Q&A or put them in the chat. Um, I'm always amazed by the extent to which isochrones are actually, an approximation of a circle in a dense urban grid. It's
Yes,
like the only time it tends to break down is if you have like a city that's built around a river or
yes.
something, some big natural barrier. Otherwise, it's like, oh yeah, a grid, and it's mostly circular.
Well, and
Um,
there definitely are some weird barriers like around highways. That was one thing that I
oh
saw
yes,
pretty
freeway
consistently.
system acts as a
Yeah.
big barrier system. Yeah,
Which are often in areas where there is higher need for these resources. So that does become an interesting problem space in and of itself.
yeah, that's history on the map. And then I don't know, did you play around at all with costed isochrones to see if that changed the shape of your shapes?
I did a little bit with some of the test stuff.
Hmm.
I haven't had a chance to really play around with it with the deliverables, but I would like to. And I'm especially interested in the data aggregation side of things. That's something I've been hoping to find some time to look into.
What
Yeah.
do you mean by data aggregation?
Like taking the census data and breaking it up into the polygon created by the isodistance and doing some um, analysis based on that, like aggregating the data into those areas specifically and comparing them
Right,
like with specific figures. Because what I like the deliverable that I presented to the Greater Cleveland Food Bank, for example, was just overlaying a census data map with an isodistance map, and that
right,
is inherently lossy because you're uh, gathering from what you can see in that overlap, not what is true about that overlap inherent to the data. So,
right.
yeah.
Awesome. That's it for my questions. Oh, we do have a question on the guest. How did you come up with 1 mile for your isochrone?
It was a nice round number, same with five. And 1 mile was nice too because we were trying to find like what the outer limit of what someone might reasonably walk to access some of these resources might be. And that felt like probably if it's more than 1 mile, it's something that would be more reasonable with transit or driving if those are accessible tools, was the thought.
Right.
Yeah.
And a question from Benjamin on the chat. Cool work. Did you try an A star as an alternative to Dijkstra, referring to routing?
No, I did not.
No. All right. Thank you so much for your time, Samuel, and for coming and
Thank you
sharing
for
that with
having
us. That
me.
was a great presentation.